Hi Year 11, welcome to the virtual open evening for A-Level Physics. During the course of this PowerPoint, I'm going to take you through some various areas which we would have maybe spoken about if you had actually been at the open evening itself. I'm going to talk about famous physicists, we're going to talk about the course entry details, we're going to talk about what kind of exams you're going to have to sit, how many papers, etc. We're going to talk about what kind of skills, what kind of topics we're going to cover, and also what kind of jobs you can go on to afterwards. One of the most famous physicists, possibly the most famous physicist, is of course Albert Einstein, and this is what he said about physics. The most beautiful thing we can experience is the mysterious. It is the source of all true art and science. Physics is often kind of looked at the big kind of heavyweight out of all the sciences because it does try to explain the very nature of the universe itself, right down to things smaller than the size of atoms, and everything else of course is built on this. So chemistry is built on how atoms add together, biology is built on even bigger things, well, cells and organs and tissues, etc. So physics is the underlying science which makes all other sciences possible, and of course without many of the inventions in physics, a lot of the other discoveries in other areas of science would not have happened, like for example the electron microscope. So you're about to see over the next 5 or 6 slides some famous physicists. Some of these you've definitely heard of, hence they're famous. Some of them you may not have heard of, but their historical background is actually quite interesting. Have a read through the information about each one of them. Which one of them inspires you? Which one of them makes you think, wow, that's really cool, that's a real achievement? So first of all, we have Dr. Maggie Aderin Pocock. She's one of my favourite presenters at the moment. She appears on The Sky of Night, has been a regular presenter for a number of years now, and I love the energy and enthusiasm she brings to the subject. So someone well worth watching. If you've not watched an episode of The Sky at Night and you're interested in space, astronomy, that's certainly something I would recommend that you do. Now, the other big heavyweight after Einstein, or maybe some would say this person's bigger than Einstein, so Isaac Newton. The list of his accomplishments is endless. He obviously put forward his theory of gravitation, he invented calculus, but he did a lot of other things as well, not directly related to the physics. One of those is that I think he was the head of the Royal Society. He also studied alchemy in his spare time, as well as languages like ancient Hebrew. So he was a right genius. People often say that although Einstein had the greatest ever thought in all humankind, so Isaac Newton was actually the most thoughtful because he kind of contributed maybe a little bit more than Einstein. Chien Wu is known as the First Lady of Physics. Although not as famous as some of the other people I've mentioned, she was an extraordinary person. At a time when there wasn't many female scientists in the actual field of physics, she did lots and lots of work on experimental physics. She worked on the Manhattan Project, which was the project which developed the atomic bomb, which ended the First World War, and really is one of those kind of unsung heroes that did a lot of work over a long period of time in the field of physics. So I thought I would include this one, George Ohm, because although you might not have ever heard of him, of course we've heard of his law, the Ohm's law, the relationship between resistance, voltage and current. So he was one of those physicists that did some solid work over 150 years ago, and is still remembered for this very important but often forgotten about area of physics. Hedy Lamarr was a famous actress back in the kind of 1930s, 1940s. Her career kind of went up and down. A lot of people don't realize, though, as well as being on the big screen, she was actually a big brain as well. So she is known for inventing technologies to do with radar. She was always very, very interested in physics and engineering in particular. There are some interesting documentaries about her out there if you ever get a chance to check them out. Galileo was a giant before the likes of Einstein and Sir Isaac Newton. Indeed, some of his writings inspired Newton to many of his accomplishments. So another real big heavyweight in the world of physics. So Marie Curie is known for her work on radioactivity. Her and her husband actually done a lot of work together, and some of this work unfortunately led to them becoming ill, them becoming sick with radiation sickness, and eventually passing on. But some of the things that they discovered, some of their accomplishments are really up there with the most important discoveries that scientists have ever made. And I've got to say, Marie Curie probably is more well recognized than her husband now. And the last one, Albert Einstein, known for his two big theories, the special theory of relativity and the general theory of relativity. Special theory is about things moving very, very fast, and how measurements of time and distance are different when things are moving very, very fast. His general theory of relativity was all to do with gravity. So if you want to do A-level physics, you need to get the right kind of grades, otherwise you will really struggle. So the minimum grades that we look for, first of all in maths and English, you can see are grade 5s. Now these are the same entry requirements as for chemistry and biology as well. And if you do combined science, you've got to get a minimum of a 6.6. So a 6.5 would not be the correct grade. You would need to get 6.6 in your combined science grade. And if you do triple science, then you need a minimum of a grade 6. Note the points at the bottom. If you are doing 2 science A levels, then you would need to get a 7.7 in combined science, or grade 7s in the 2 science subjects that you want to do. Okay. If anyone wants to do 3 A levels, then again, a 7.7 in combined science will be enough, or grade 7s in all 3 separate sciences. Now, if you want to go into more detail and look at the exact objectives and criteria that we would study in A-level physics, I've provided the details here. So the specification we follow is OCR A, and there is a link which will take you to the specification where you can read up at your own leisure. I will go on and just talk about some of the more important points in the next few slides. Okay, so A-level exams, you need to sit the examination themselves at the end of year 13. So this is what you will be given at the end of year 13. There are 3 exam papers altogether: modelling physics, exploring physics, and unified physics. So this table just tells you how many marks you're going to be given. The first 2 exams are quite lengthy, so 2-hour 15-minute exams. The third one is only an hour and a half, but that is often looked at as the most difficult paper, because the third paper combines everything that you've learnt over the 2 years. The first paper, paper 1, only looks at topics modules 1, 2, 3 and 5, and the second paper 1, 2, 4 and 6. Okay, so there are 6 modules altogether, and paper 3 looks at all 6 of those modules. There's also something called the practical endorsement in physics. So what this is an area of practical work which you have to complete. There are 12 tasks altogether that you would complete over the 2 years of the A level, and if you pass all the criteria for those 12 practicals, then I basically send off a document to the examination board saying that I think you have passed everything, and then when you get your certificate, as well as having the grade that you've got in physics, underneath that it will say practical endorsement, pass or fail. You'll also be asked questions on practical work in the actual exam itself. By the way, there are no formal exams, no external exams for you to sit in year 12. However, whether you get onto year 13 or not is dependent upon your passing the year 12 progression exams, which normally happen at the end of year 12. There are also regular tests which occur throughout the year, so you've got to make sure that you start year 12 not trying to catch up, but you start year 12 getting the kind of grades that you're aiming for in the end of unit tests as well. It's no good not revising for those tests and getting low grades and then expecting me to say, right, if you do well in the end of year exam, I'm automatically going to say you can go through to year 13. We do look at your progress during the course of the year and ensure that you are the correct kind of student for physics, and also that physics is the correct kind of subject for you. Okay, we don't want you to waste your time, so you've got to make sure that you show us exactly what you are capable of in the subject from the very start. Okay, so this slide just gives you some details about the topics which we cover. Many of these you will remember back from the GCSE Caboodle books that you're used to. So motion, forces, work and energy, so that's largely what you've done at P2. Materials, it's like taking Hooke's law but a little bit further, not just looking at springs but looking at materials in general. Electrical circuits, well, that's essentially what you've learned in P3, a bit more detail. Wave behavior, so you've done some topics depending on whether you've done triple or double. The units might be P4 and P5, so that's waves. Quantum physics is a completely new topic that you haven't done at GCSE. We don't go into huge detail here, but the few lessons that we do are very interesting. Practical skills I've already mentioned, and although I've only written practical skills under year 12 here, obviously that continues into year 13 as well. And then in year 13 you've got additional topics, so momentum and circular motion. That's now like thinking about P2 but in more detail, more advanced level. Fields, electromagnetism and oscillations, so that's a mixture of the work that you've done on electric fields, gravitational fields and magnetic fields, motors and generators and transformers. And oscillations, that looks at waves but in a slightly new light. Thermal physics is a continuation of what you've learnt in P1. There's also some chemistry in that. Nuclear physics and fundamental particles is all about the atom, all about the nucleus, different types of radioactivity. And then there's a whole section on cosmology, which includes the Big Bang Theory, the evolution of stars, how we make certain measurements. So for example, how do we measure distances to objects in space, etc. Okay, the next couple of slides just go through lots of skills that you would gain if you did a course in physics. Now I won't read through every single one of these word by word, but just looking at the left hand side, so we're talking about problem solving. That's an obvious one. Okay, reasoning. So both those problem solving and reasoning, those skills are kind of drawn out by the kind of calculations that you have to do. Some of those calculations are quite complicated, not simple kind of one-step, two-step calculations. There might be multiple steps involved. You have to think about how to approach a question, how to translate the information that you're given in a question. There's also some research and data analysis, so looking at graphs, looking at tables and understanding what's the information, what the data in those contexts, what it means. Numeracy, So looking at various skills. When we talk about maths being important for physics, don't worry about maths as in A-level maths. Your GCSE maths has to be very, very strong. So all those basic things like the algebra, the trig, the geometry that you've learnt, that has to be very, very good, very, very sharp. If those are weak areas for you, then you will struggle with a physics course, because we of course go at quite a fast rate. We try and get through all the content, and if you're having trouble rearranging equations, then you're not going to be able to go on and master the more complicated, the more advanced skills. Okay, so make sure your basics in maths are in place. Okay, this slide shows you slightly more general skills. So obviously practical skills, so planning practicals, carrying practicals out, reporting, writing reports on those experiments, using the technical equipment that you're given. Communication. So this is vital in any area that you want to go into. It's not all about numbers. You do have to be able to write a few words of English, string some sentences together, and explain some complicated ideas. There's team working skills which develop as well. Some of the work that you do, some of the practical work you do, you will do that in groups. You also have to be good at managing your time and organizing yourself. I'd say that for all A levels, and of course any kind of skills that you have in IT would be useful here, particularly when it comes to kind of finding information on the internet. So maneuvering around the internet, various websites, accessing resources, questions, information, and then using that to enhance your knowledge of the subject. Now, Physics A level shows a various breadth of different skills, as I've just gone over with you on the previous two slides. I remember when I was at university, at University College London, we were studying something, it was a course called Physics, Electronics and Computing. So all my colleagues, people that went through this degree with me, they went on to various things. So I became a teacher, some people went on to work in the computer sector, some people went into banking, some people went into accountancy, some people went into TV. There's actually a TV presenter who was at UCL with me, and he now has presented over the last few years. I've seen him on various BBC programs. So a physics degree really leaves a wide range of topics for you to go into, because you're showing them that you're logical, you're numerate, you're a good thinker. So there's lots and lots of areas that you could go into with a Physics A level. Not just engineering and science-based industries, but as you can see in my second bullet point there, finance and banking, as well as other areas. So here is a list of places that you could apply to with a physics background. If you are interested in any of these, I would say to you, go and do your research, find out more about them. Okay, this is my last slide really. I just want to say that if you are thinking of doing physics, it should be fun for you. You should enjoy doing the subjects that you're choosing at A level. You're going from maybe up to 10 different subjects at GCSE down to just 3. So you should pick something that you know that you are going to enjoy. A lot of people who do physics at A level, they like the problem solving aspect of it. They like working with numbers. They like their maths. And so that feeling, that reward that you feel after you've solved a problem, you get that in physics, you get that in maths. So it's a reason why a lot of people take up physics. And I think the most successful students are always those that kind of share their ideas amongst each other. So a few years ago, for example, our best ever results were virtually every single student from the cohort got an A star, an A, a B or a C. I think we may have had one D if I remember correctly. The thing about them was they had some fun as they studied for their A levels. So they had their own social media groups where they would share ideas, they would share a joke or two, they would help each other out, they would put resources onto the group. So it should be fun. You should enjoy working with the rest of your peers and not just kind of be in a place where you think you're on your own having to work through these obstacles. Okay. The following slides, the last few slides, just get across some of the humour in physics. So have a look through, enjoy the jokes, see if you understand the jokes, and if you do decide to do physics next year, it will be I look forward to seeing you at the start of your year 12. Thank you, everyone.